Today we're moving on to the last unit, which is Unit 11, which is predominantly over space, or is over surface area and volume. Today we're just doing an introduction to really surface area. So this unit, as I said, surface area and volume, we are looking at polyhedron. Polyhedrons are 3D figures made of polygons. And you may or may not remember, but polygons are figures made up of segments. So for example, this picture that we have here is a polyhedron. It is three-dimensional. Each one of those sides are made up of polygons, specifically squares or rectangles. This guy has a name, and we'll be working on that some as well later. This is called a rectangular prism. The three items that they're pointing to here are specifically for polyhedrons. All of these sides of the prism are called the faces. Those are the planes, or your flat surfaces. This arrow is pointing to this right here, which is what we call an edge. And this guy down here is referring specifically to that point, and we call that a vertex. There's one specific formula that relates the faces, the edges, and the vertices, and that's called Euler's formula. And it says the number of faces plus vertices should equal the number of edges plus 2. Well, let's take a look at this specific prism up here. The number of faces, well, we've got these four sides around here and the top and the bottom, so that is 6 faces. We take the vertices, again, those are kind of the corners. There's 1, 2, 3, and 4, 5, 6, 7, and 8. And that should equal the number of edges plus 2. And again, we want to try and count this in some organized manner. If you take a look at the top, we've got 4 edges here. You've got another 4 down in here, and then you have another 4 here. So if you take a look, that's 3 times 4, which is 12 plus 2. And if you notice, 14 does equal 14. So let's look at a few examples. It says using that formula, we want to find the number of edges on a solid that has 6 faces and 8 vertices. So I'm substituting in the 6 faces, substituting in the 8 vertices. I'm looking for E, and I've got a plus 2. So when I substitute in, I have 14 equals E plus 2. Eventually, E is equal to 12, and we've got 12 edges. The next one, it says use Euler's formula to find the number of edges on a polyhedron with 8 triangular faces. I'm not sure I'm going to be able to draw this, but let's give it a shot. So if you can envision, I've got a triangular face here. Kind of have one back here, and then there's like a 4th one sitting back in there. So you've got 4 faces up in here, and then we would actually have the same thing below it. So let's take a look. We're looking for the number of edges, so we have faces plus vertices equals edges plus 2, and you might say, well, look, I can just count the edges, and you're right, but let's go through also using that formula. So it says we have 8 triangular faces, so that's 8. We don't know the edges, so let's go take a look at the vertices. I have 1 up here, 1 down here, and I've got 1, 2, 3, and 4 there. So we get 12 equals E plus 2. We end up with E is equal to 10. on to example number 2. As I said, our first goal really is going to be to look for surface area. One way we can do that is we go and we take a look at the net. This is a net of this figure. First of all, let's talk about, again, how we name it. It's a prism because all of the sides, or the main sides, are rectangles, and if you take a look at the base, which are the top and the bottom, those are the pieces that are what we say are parallel, we would call this a pentagonal prism. And a net specifically is a 2D figure when folded creates a 3D polyhedron. So if we take a look at the prism, or excuse me, the pyramid that we've been given here, and again, this is a pyramid. I know it's a pyramid because all of the sides, other than the base, are triangles, and specifically, if I go and look at this guy right here, that's how I name this. That base is a square, so I would call this a square pyramid. They want us to draw a net and label the net with its dimensions. So what I'm going to do is envision that base is right here, and if I place that in the center and I literally peel back all the pieces, each one of those pieces, which we'll eventually call lateral faces, are triangles. And I've been given 2 dimensions. First of all, I know this length in here is 8, and they're also showing me that this length in here is 10. Saying each of the 4 isosceles triangle faces is a side of the square. So let's go take a look at question 4. Again, they've given us a net of a rectangular prism. They want us to draw a different net and show its dimensions as well. So I'm going to kind of plan it out like I did this one. I see the base of this as the bottom of my cereal box. So I'm going to go ahead and draw that in. And I've got 14 and I have 7, and again I'm just going to kind of peel back the pieces. I'm going to peel off the front, which I see to be here. I'm going to peel off the left side, the right side, peel off the back, and then the only other thing I have to do is attach that top. I can attach it anywhere I want just for sake of room. I'm going to attach that piece right in here. And the only other thing I haven't labeled is the 20, which is here, which would correspond with this part here, or even this part back there. Now, as I said, one of the things we're going to be looking at is surface area. So let's go take both of these and look at taking it one step further. Surface area is truly the area that it takes to form either one of these. So let's go start looking at that. If I take a look at this rectangle, which is the bottom and the top, those actually have the same area. And I'm going to go over here and place it here. Actually, maybe we'll squeeze it in up here. I've got 2 of those rectangles, and each of those rectangles are 4 by 17. Then, if I go and take, and I'm going to use my colors, if I go take a look at this one here, and this one right here, which is the left and right of my box, both of those are the same. Again, they're rectangles, so I have 2. This length is 20, this length is 7, so I have 20 times 7. And then finally, if I look at the front of my box and I look at the back of my box, those are the same dimensions. Again, I have 2 of those. Notice this is 14 by 20. I'm going to pause this and plug it into my calculator. Okay, I went ahead and plugged it in. I end up with 1,036 centimeters squared. Let's go down to 5, and then if we have time, we'll jump back up and do number 3. Question 5, it says, is the pattern a net for a cube? If so, name the letters that will be opposite faces. So again, if you can envision, leave that B at the bottom. That would be the base of my cube. So the pattern in this case is a net, because you can fold it. After the net is folded, the following pairs of letters are opposite faces. So they want us to look at the back and the front. So if we leave this to be the bottom, the back and the front would be these two pieces here, which are C and A. Let's go down here. They want the right and left. So if you can envision, if I fold this up, my D would be on my right, the E would be on the top, which then kicks the F to be the left side. And then finally, we've got the base, which was the B. When I fold it, the E ends up on top. So these are the bottom and top faces. Now, I know they didn't ask you to do it, but we could even go find the surface area of this cube. And I've been told it's a cube. We figured out it's a cube, and we know all sides in a cube are the same. So let's pretend each of those sides were 3. Well, if I go find just the area of B, that would be 3 times 3. And if you notice, every single one of these faces are the same. 1, 2, 3, 4, 5, and 6. So I really have 6 faces that have an area of 9, and I would end up with a surface area of 54 units squared. All right, let's go back up to number 3 and see if we can find the surface area on that one. So back up to number 3. First thing I'm going to do is go after the easy part, which is the base of it. It's a square. I know that is 8 times 8. Then my remaining figures, while they're not perfect, they're supposed to be the exact same. Each one of those are triangles. That means I have 4 times 1/2 times base times height. So we've got 64 plus 4. The length of the base of one of those triangles is 8. What I don't know off the top of my head is the height. This 10 right here goes here, so what I really need is the height in there. So we've got the skills to do it. Let's go down here. We can use Pythagorean's theorem. X squared plus 4 squared equals 10 squared. I have 100 minus 16. That would give me 84, and we're just going to go ahead and plug that in our calculator. The square root of 84 is approximately 9.2. So we can go back up, plug in the 9.2. Again, that represented this height. Each one of those triangles have the same area. We get 64 and 294, and I left off my 1/2 in here. Give me just a second to fix that. Okay, I went back, I plugged it in, I got 147.2. Finally, I'm going to add the 64, and we end up with 211.2. Again, in this case, centimeters squared. Alright, tonight's assignment is on MathSpace. It truly focuses mainly on nets and how we label these, with a few surface area problems as well. As long as you complete the assignment and you get a score of at least 50%, you will earn